All right, welcome to today's little lesson about linear and exponential functions. So we're going to do a few examples from this little review that you have before you. But before we do, let's do a quick recap of what these functions or equations look like. And I do want to reiterate that if it says y, you can also put f of x, and it means the same thing. And you're going to see that a lot on the review. There's some y's. You'll see things like f of x, g of x, and they mean the same thing. So they're interchangeable for the most part. But yeah, there's a difference between linear situations, linear equations, linear functions, and exponential ones. And the key thing that makes something linear is if you're adding or subtracting the same amount each time, each iteration of it. So this is like you give every person in your class 2 cookies. You sell something for $11 and 5 people come by, right? That'd be you sold for 11. So you got 11. It's just adding 11 each time. Exponential is different on the other hand though. Exponential means you're multiplying or dividing by something over and over and over again. And this thing like if you're doubling or tripling, quadrupling things. It also deals with percent change, repeated percent change. So let's say the population in some cities going up by 1.3% a year. Then that's a percent change that happens over and over. That's also exponential. And the equations are these. Right? Most people by this point are familiar with linear equations, y equals mx plus b. Exponential ones do have a format that they follow. It's y equals a times b to the x power. And that's if it's just like times 3, or you're halving it each time. So times half, or times by 3/5, times by 3/5. Or if you have percent change, then it's this guy. Y equals a times 1 plus or minus r to the x. This r here is your percent. So if you're going up by 3%, you put plus 0.03 because your r has to be as a decimal. Or if you're losing 17% a year, you're going to minus 0.17 because it's 17% as a decimal. So those are your basic functions. That's the format they go in. Let's look at a few examples from your assignment that directly relate to that. So we're actually not going to do a few on the front first. We're actually going to jump to the back and go to 9 because that 9 has these situations and we're going to write out the functions for them. So we're looking at 3 and 4. So on 3, 60% of a town's population is leaving each year due to a viral outbreak. Before the incident, there were 40,000 people. So this here is my initial value. That's the A value of my equation. The 60% here is what's leaving each time. So that's my R value. This percent change over and over is R. And so I'm going to write it out. I got Y equals A, which is 40,000. And then in parentheses, 1 and r to the x power. This one, you do have to figure out whether you're adding or subtracting. It's like, are you going up by 60%? Are you going down by 60%? I'm actually going to put 60%. 60% is 0.6. Is it plus or minus? And you have to figure that out. You have to think about it. This one says it's going down by 60%, so I'm going to put that in there. And that does require a little bit of simplifying. So I'm going to simplify a little bit. 1 minus 0.6 is 0.4. And now I have my equation. This would be exponential. I believe it asks you for exponential, whether it's linear or exponential. Let's look at 4. It says, just a town has a problem keeping its cat population of 40,000 happy. Each year, 60 of them run away in disgust. So if you... This 40,000 is again our initial value, which for this one, you have to think, is it linear or exponential? This is just subtract 60, subtract 60, subtract 60. So that makes it linear. And so 40,000 here is going to be my B value, my initial value. And then the 60 here, this is what it's changing by. That's my slope. And so I'm going to write out my equation. And let's do function notation this time. We'll do f of x equals, and it's mx plus b. My m value is 60, and my b value is 40,000. But there is something missing on this. This would say it's going up by 60 each year, but it needs to be going down by 60. So I'm going to make my slope here negative. And now my equation matches the situation. So now we've kind of had a little recap of exponential versus linear situations. Let's also review how to graph them, because that's an important part of the function, to be able to read them. We're going to do 6 as an example. This is a exponential function. I can tell it's a times b to the x power. And so to graph this, we're going to make a little table. And the table just helps you, get some points on there so you know which way things are going. I tend to pick x values that go close to 0. And I want to get like 5 of them so I can get a good feel for what the curve does. And you can plug each of these in for your exponent. Put it in, you got 5 times 1/2 to the negative second power, and you'll get a value and you can write it down. Or you can remember what these things represent. The 5 here is your initial value, which is a. It's your y-intercept. So I can go to my table, to my y-intercept value when x is 0, and put 5. And I know that this is what it's multiplying by. It's the growth factor. And so I'm going to times by 1/2 repeatedly. As I go down my table, it's times by 1/2. So I take 5 times by 1/2, you get 5 halves. 5 halves times by 1/2 gives you 5 fourths. And if you're going to go the other way, it is dividing by 1/2. Well, dividing by 1/2 is timesing by 2. So I'm going to go up here and times by 2, I get 10. Times by 2, I get 20. And if you want, you can check any of these. Like you plug in -1 here, put in your calculator, 5 times 1/2 to the negative first power, you'll get 10. But you can check in and make sure. So I got these points, and these are just points. Each row makes a point. So I got the point -2, 20, which is here. I got the point -1, 10 here. And I'm just plotting all these points that I have. 5 halves is 2.5. And then 5 fourths is 1 1/4. I got that. So I'm going to connect these up like so. But I do want to point out what happens over here. So I'm going to add another number here. If I times by 1/2, I get 5/8. If I times by 1/2 again, I get 5/16. So it's getting smaller and smaller and smaller. But this number here on the right side is never, ever going to get negative. Because if you times by 1/2, it's just going to make it smaller, but it's never going to get below 0. You'll get like 5 over 2048, and that's still positive, though it's really small. So that's something to remember about exponentials. They'll curve towards your asymptote. That's this line it gets infinitely close to, but doesn't cross. So that's graphing exponentials. Let's do a quick review of graphing lines, so you can have that. Remember, we want the format y equals mx plus b. This is not in that format, and so we're going to make it. So let's subtract off the 2x. Now I got -3y equals -6 minus 2x, and divide everything by -3. And now I got y is 2 plus 2/3 x. It has a y-intercept of 2. Slope at 2/3, so I go up 2, right 3. And I can get another point, up 2, right 3. You can also go down 2 and left 3, down 2 and left 3. And sketch out your line. It's a very, very beautiful, absolutely perfectly straight line. Just kidding. But yeah, there you go. So that's a quick recap of how to graph those, and that's it. It's just graphing more lines. It has a y-intercept, it has growth factors. Well, this has a slope, constant slope. This has a growth factor of 1/2. And so it's kind of a quick recap of linear and exponential functions. And I'm going to scroll back to this if you need to write some of this down. And good luck with exponential and linear review.